Now we're going to look at the ellipse on the complex plane. So we go back to the definition of an ellipse. On the complex plane, the ellipse is the locus of a point z which moves so that the sum of its distance from two fixed points is constant. The fixed points z1 and z2 are the foci of the ellipse. So let's just have a quick look at what this is. Here's two fixed points, z1 and z2. Now here's some other point, movable point z. Remember, z can move wherever it likes. And what the definition says is that the sum of its distance from two fixed points, that is, that distance plus this distance, must be a constant. So in other words, this distance here would be z minus z1 magnitude. Remember what we did right at the start. This distance here would be z minus z2 magnitude. And so what the definition is saying is that z minus z1 for an ellipse, z minus z1 plus, because it's the sum, z minus z2, this distance plus this distance must be equal to a constant, and we're going to call that k. Now, if we were to imagine, and this is something we may try in class, if you were to imagine this as a piece of string, so imagine this as a piece of string, I'll just wriggle it in a bit, and we had a drawing pin here and a drawing pin here, the two foci, and we put our piece of string, our pen, in the string and pulled it nice and tight, and then we moved our pen around keeping that string tight. What we would actually do is we would form an ellipse with z1 and z2 being the foci. Now, a couple of useful things here to note. K is actually the length of the major axis. K is this length plus this length. If you imagine when your pen is out at this point here, right at the vertex of the ellipse, the string is going out here, around your pen, and back to there. If you were to imagine this, you cut that little bit off there and place it over here, and then the string would go from one end of the ellipse all the way to the other end, which would be the major axis. So k is like the length of your string, that distance plus that distance, and it also then is equivalent to the length of the major axis. Okay, so how do we actually sketch an ellipse and show the key features? Well, let's look at an example of that. Sketch z minus 1 minus I magnitude plus z minus 5 minus I magnitude equals to 6. Okay, first of all we need to recognize that this is actually an ellipse. We know it's not a straight line because we don't have one distance equals another distance. We know it's not a circle because we don't have magnitude equals a constant. We do know it's an ellipse because we've got one distance plus another distance equals a constant. So that is the standard form of an ellipse. Now remember that the standard form is, as always, z minus z1, because the distance between 2 points is subtracting them. So to put it in standard form here, we'll have z minus 1 plus I plus z minus 5 plus I equals to 6. So we know this is an ellipse. Foci at z1 equals 1 plus I, z2 at 5 plus I. There's our two foci, and we know our major axis equals 6 units. So when we come to sketch this time I probably will use a ruler. We've got foci at 1 plus I and 5 plus I. So we're going to need a little bit more on the right hand side of our graph. Imaginary, real. Okay, so we mark on our two foci. That's the first thing we can do. So at 1 plus I, which will be there, and at 5, 1, 2, 3, 4. There's our two foci, Z1, Z2. Now, if we've got a major axis of 6 units, in order to mark the major axis on, we first of all need to know where the centre of our ellipse is. Now in this case, if your foci are here and here, we always know our centre is halfway between the two foci. So it's pretty easy to tell that the centre is going to be right there. If it wasn't so easy to pick for some reason, then you could say ZC, C for centre, is Z1 plus Z2 divided by 2. In other words, average the two foci. If you average them, you'd get 1 plus I plus 5 plus I divided by 2, which would be 1 plus 5 is 6, plus 2I over 2, which would be 3 plus I, which is exactly what we knew it would be anyway. Okay, so you can just do it by inspection, just looking at your graph. Alright, so here's our centre. Our major axis is 6 units long. So that is, I'll go 3 units either side of the centre. 3 units either side. Well, if I go 3 units this way, I'll go 1, 2, 3. I'll be up to 6. And I go 3 units this way, I'll be back to there. So here are my vertices on my major axis for my ellipse. Now the only thing here is before we can draw our ellipse, we don't know how fat or how skinny to draw it because we don't have our minor axis. And so we just need to pause for a sec here and remember or think about how can we work out how far up or how far down, in other words, what's the length of the minor axis in this case. To do that, I'm going to draw another little quick sketch underneath here. Okay, so here's just any old ellipse. There's the centre, here's the two foci. Now, at the time when, as you're drawing your ellipse, when the string is going up around your pen there and back down, in other words, when you're directly above the foci, I know that this plus this must be equal to 6. Okay, at the moment that the pen is up here, this distance plus this distance must be equal to 6. From the equation. Therefore, I know that this distance must be 3. Now, I'm going to draw a little right angled triangle here. Now remember, this is the foci. That's the foci, this is the centre. What's the distance between the foci and the centre? Be careful, it's not 3. Okay, that's between the foci and the vertice. Between the foci and the centre is 2 units. Now, I can use Pythagoras rule to find that distance there. I can use Pythagoras rule to find that. So I know that 2 squared plus y squared equals 3 squared. So y will equal the square root of 3 squared minus 2 squared, or y will equal the square root of 9 take 4, which is 5. So I now know that my semi-minor axis is square root 5 units. Now, you know that square root 5 is going to be a bit over 2. So I'm going to come up square root 5 units, and I'm going to go down square root 5 units. So I'm going to be down about there. And I can label that point. I can label it as 3, 1 plus square root 5. And down here it will be, and you could actually get your calculator and might be easier to get your calculator and actually write that as a decimal. So we'll take that out. So 1 plus square root 5, 3.23, and down below it'll be 1 take away square root 5, negative 1.23. And now we can draw in our ellipse. There it is. So the hardest part of drawing the ellipse is actually working out the minor axis, which I strongly recommend you draw a little diagram like this to help you work out your semi-minor axis. Okay, just keep in mind that that distance plus that distance was our value of 6 here. Okay, and so that is sketching ellipse. By the way, if we were sketching a region, if we turn this into a region, if that was a less than or equal to sign, then we would shade inside the ellipse. If it was a greater than or equal to sign, we would shade outside the ellipse. If it wasn't an equals, if it was just a less than, then we would dot the boundary and we would shade inside if it was just a less than. So we can combine what we were learning before with regions along with ellipses as well.